This is Isotopes Practice number 2, or task 11 in Canvas. So carbon 12 and carbon 14 are isotopes. They are the same element with a different mass. Because they're the same element, their atomic number, or the number of protons in the nucleus, must be the same. Each element's atomic number is listed on the periodic table. The number of neutrons can vary, which means it can change. Carbon 12 has a mass of 12 because it has 6 protons and 6 neutrons. 6 plus 6 is 12. Carbon 14 has a mass of 14 because it has 6 protons and 8 neutrons. 6 plus 8 is 14. Notice that the number of protons for the same element must be the same. So carbon 12 has 6 protons and carbon 14 has 6 protons. They both have the same number of protons, 6, because they're both carbon. The number of protons determines what the element identity will be. And then here's just an example of the shorthand again. For each of the following neutral atoms, give the chemist shorthand. You will need your periodic table to look up the atomic number. For each of these, they've given us the isotope name, which is the element name, and then the mass number. First two I did for you. So the atomic number for chlorine, when we look it up on the periodic table, is 17. So that's where that number comes from. The 36 is given, so that's the mass number. It goes on top. And Cl, the symbol for chlorine is Cl. Sodium 22, this is number 2. Sodium, the symbol is Na. 22 is the mass that is given, so you just pop that in there. And then we look it up on the periodic table, and the atomic number is 11. Okay, so uranium, 236. So 236 is the top number, that's the given. The symbol for uranium is U. Look up our periodic table. U is on the bottom. It's going to be number 92. The atomic number is 92. Sulfur 32. Sulfur has a symbol of S. 32 on top. And when you look it up on the periodic table, the atomic number is 16. I know a lot of these by heart already, so I'm going to skip the looking it up on the periodic table for now. But again, this bottom number is just finding it on the periodic table. Boron 12, so the symbol is B. It's going to be 12. That's the given. And then looking it up on the periodic table, you should find the atomic number is 5. Iron 56. So iron is Fe. 56 is given as the mass. And when we look it up on the periodic table, the atomic number is 26. Chlorine 35. So it's going to look a lot like number 1, our example. So Cl 35 over 17, but just a different mass. Sodium 23, it's going to look like number 2, except a different mass. So it's going to be Na 23 over 11. Magnesium 24 is going to be Mg, and then the numbers are going to be 24 over 12. Which atoms above are isotopes? Hint, there are 2 pairs. So one of our pairs is chlorine. There's those 2. They're isotopes. They have, they're the same element. They're both chlorine, but the masses are different. And then the other pair is the sodium atoms. So there's sodium 22 and sodium 23. They're both sodium, but the masses are different. So we have sodium 22 and sodium 23. And then we have chlorine 35 and chlorine 36. So writing it like that, where you do the symbol and the mass number, is just a shorter way to do the isotope name. And so we said how we know they are the same element, but they have a, they have different masses. So if they're the same element, then that means they have the same number of protons. If they have different mass numbers, that means they have different numbers of neutrons. Okay. On the next page, because this one was 2 pages, for each of the following generic chemical shorthand symbols, look up the element using the atomic number and name it. Also determine the number of neutrons. So for each of these on the shorthand, they just put in an X. So they didn't tell us the element. So we have to look that up using the atomic number. So if we look up the element that has an atomic number of 5, we'll find that it is boron. And then we just use the mass here, and that goes in there. And then you just subtract the 2 to find the neutron. So 12 minus 5 is 7. All right, so on the next one, the mass is 15. So that's where that number is coming from. The atomic number is 6. So when you look up 6 on the periodic table, you'll find that it's carbon. So this is carbon 15. And I did have a little mistake here when I made this. 15 minus 6 is not 11. It is in fact 9. 9 neutrons for carbon 15. I can write that a little bit neater, I think. There we go. All right, so for the next one, 7, the atomic number 7, that's going to be nitrogen. So nitrogen 15, and 15 minus 7 is going to be 8 neutrons. Okay, number 15, again, atomic number is 7. Look it up on the periodic table. You'll find that it is nitrogen. This one's going to be nitrogen 12. 12 minus 7 is 5. 5 neutrons. The next one, the atomic number is 4. That's going to be beryllium. Beryllium 9. 9 minus 4 is 5 neutrons. Number 17, the atomic number is 5. That's just like up here where the atomic number was 5. That was boron, so it's still boron. Boron 9. So 9 minus 5 is 4 neutrons. 18. 8, atomic number is 8. That's oxygen. And this is going to be oxygen 15. Again, you just need to look it up on the periodic table. 15 minus 8 is going to give us 7 neutrons. Number 19, the atomic number is 6. So that's going to be carbon. That's going to be carbon 11. 11 minus 6 is 5 neutrons. And our last one, the atomic number of 11 is sodium. So this is sodium 23. And 23 minus 11 is 12 neutrons. And they want to know which ones are the isotopes. There are 3 pairs for up here. So we've got boron and boron for 1 pair, boron 12 and boron 9. Okay, we've got 2 carbons. We've got carbon 15 and carbon 11. And then our last pair is the 2 nitrogens, nitrogen 15 and nitrogen 12. Okay, and again, how do we know? They are the same element, but they have different mass numbers. So I'm literally just going to copy and paste my answer from number 11 up here and put that in for number 12. Okay, and that's Isotopes Practice number 2 or task 11.